Hi everybody, I'm Mike Nelson and we are into the cold season now, the November in Colorado coming our way. Mountains get some big snows in November. We get some big cold snaps every once in a while, Denver across the eastern plains, and we can get big snowstorms too. Matter of fact, back in 1946, one of the biggest storms on record, the 2nd, 3rd, and 4th of November. That was also the wettest November ever. When you melted all that down, it was over 3.2 inches of liquid. The driest was only a few years later with a trace of precipitation in 1949. The big snows were in 46, 42.6 inches for the month. But just recently in 1991, I remember this one, 29.6 inches of snow during the month of November. 7.4 is the average monthly snowfall. Hottest temperature late in the month, surprisingly, back in 2017 on the 27th, 81 degrees. Spin those numbers around and add a minus back in 1877 on the 29th, 18 below. That's the all-time coldest. The average high is 59 on the 1st, drops to 47 by the 30th. The average low, 31 on the 1st, drops to 21 by the end of the month. Our main storm threats shift a bit. We can still get some heavy rain, but it starts to move over toward dense fog, sometimes freezing fog, and snow and very cold conditions. As we head toward the winter season, we'll see those take over as the main weather threats. Snowiest November, spoke about November 1946 with over 42 inches of snow. 1991 had 29.6, the second snowiest. 83, that was a storm near Thanksgiving, over 29 inches. This is kind of interesting. 23.1 in both November 29 and a year earlier. November 1908 saw almost 23 inches of snow. In 1979, 22.3. Now, winter outlook has been issued by the National Oceanic and Atmospheric Administration, and it calls for warmer than average conditions over southwest Colorado, colder than average conditions over the northern Great Plains and the Pacific Northwest, wetter than average in the Pacific Northwest as well as around the Great Lakes, and a little drier than average over southern and southeastern Colorado. That really speaks of a La Nina weather pattern. Third straight year of La Nina. That manifests itself in a northwest to southeast jet stream flow for most of the winter. It'll shift a bit, but I'll explain that more in just a bit. That tends to favor the northern and central mountains with the heaviest snows. The storms tend to be fast moving, which means they don't stick around long enough to bring us a lot of snow on the eastern plains, but it can happen. We did have March of 2020, a pretty big storm during a La Nina winter. It's oftentimes windy on the plains, and we do get a couple of good shots of cold air. So La Nina is the cooler cousin of El Nino, and that's cooler water conditions in the equatorial Pacific. Changes the energy balance for the jet stream, and we tend to get a northwest to southeast flow across the nation, and that brings fast-moving fronts that favor the mountains of northern and central Colorado at the expense of southwestern Colorado and down into New Mexico. We'll see what happens. We could use a good soggy winter, but not as much as other parts of the West. The extreme drought continues to the west of us and to the east and south of us. Parts of Colorado are still in relatively good shape right now, and as the winter season comes in, we'll hope that that La Nina certainly improves things over the northern and central parts of the state as much as we can. Hey, you want to help us measure the storm? Join COCORAHS, the Community Collaborative Rain, Hail, and Snow Study. We have 20,000 COCORAHS volunteers around the world. You learn how to measure the rain, the hail, and the snow. You get a rain gauge, and it's very easy and fun to do if you're a weather enthusiast. If you want to learn more, go to their website, www.cocorahs.org. As we like to say, go cuckoo for COCORAHS. All right, let's talk about the 30-day forecast. Right now, that looks drier than average across Colorado and warmer than average for the month of November. And of course, that does kind of feed into what I showed you for the winter outlook. We are seeing a trend with climate change for warmer weather in the fall into the winter. And this trend goes back at least the last 50 to 70 years, warming across the West. And we're going to continue to see that. With climate change, we're seeing a lot of things globally. Record-setting wildfires, heat waves and droughts that are worse, shrinking snow and ice, and extreme rainfall and flooding. It's all related to a warmer world. But this one is a little counterintuitive. There's something called Arctic amplification. Warmer temperatures in the far north are meaning there's less of a north-south temperature contrast, and that's what strengthens the jet stream. And so that means the jet stream loses some of its speed. Now, if you think of a fast-moving river that kind of goes straight through versus a meandering stream that moves slower, that's what can happen to the jet stream. And so what we get are these more windy patterns, and every once in a while that can allow really cold air to go much further south. Remember, regionally, Texas had that severe cold wave a couple winters ago. So even though the world is getting warmer, because of that and something called Arctic amplification, you can actually get local effects where you can get a regional cold snap. Now, we know the warming is from carbon dioxide produced from the burning of fossil fuels. We can measure it. These are all the main measuring sites. And we have Barrow and Mauna Loa, American Samoa, the South Pole. This trend represents the growing season, because during the growing season, some of that carbon dioxide absorbed by plants. And then when those plants die in the fall into the winter, that carbon dioxide goes back into the atmosphere, and that's why we see this change. But basically, because of the burning of fossil fuels, carbon dioxide increases every single day. And it's been doing that, and it acts like feathers in a down comforter that trap heat that would otherwise escape into outer space. We're seeing those global temperatures continuing to rise. So it's very simple. It's a blanket of CO2 that's increasing, trapping heat that would otherwise escape into space. Add heat, get warmer. It's that simple. And it's going to stick around a long time, because that atmospheric carbon dioxide will stay in the atmosphere. We call it residence time for centuries. As a matter of fact, the carbon dioxide from the first Model T is still in the atmosphere, causing the Earth to warm. You want to learn more about this? Check out the book on climate change that I wrote, along with a couple of local authors. Dr. Peter Tons is one of the world's foremost authorities on global carbon dioxide. You can get a free download. Just check this out. That link will click in and you can get a free download, 10 facts in 10 minutes about carbon dioxide.